afternoon to you. It is great to have you here. As part of the nation's push towards a digital future, ITE has organized the annual Digitalization Challenge, pushing towards the digital economy in the future. With this Digitalization Challenge, we are bringing in some industry partners to provide the necessary resources to support competing teams. One of the categories this year is data analytics. This year, we are fortunate to have with us two professionals from the industry who are experts in their industry domain, and they have also used data analytics as part of their daily work. We hope that through this sharing session, it will help you to connect the dots between what you are doing for the digitalization challenge and how it applies to the world around you. Without further ado, I would like to introduce our first speaker, Mr. Faisal Rahman from Food Panda. So Mr. Faisal, please. Okay, just hold on for a short while. We're having some technical difficulty. Mr. Faisal will be with us in a couple of minutes. Please hold on for a short while.
Hello.
Hi, Mr. Faisal. Good to have you with us. So announcing our first speaker again, Mr. Faisal Rahman from Food Panda. Mr. Faisal, please.
Okay, thanks, Hafiz. Yeah, sorry guys, had some technical issues just now. Okay, let me just do a very, very quick intro about myself. I am the finance business partner for global product and tech. So I essentially run the full stack of financials for the product and tech teams in Food Panda. So we have a team based in Berlin as well as APAC. Can we move on to the next slide, please? Okay, so this is a little bit about myself in terms of career history so far. So I started out my career in P&G as a financial analyst, where I essentially own product pricing strategy for perfume brands such as Gucci, Hugo Boss, and Dolce & Gabbana. And after that, I progressed straight into the tech space for ride-hailing and food delivery. I started out in Uber primarily, so that's where I ran the marketing finance budget for the APAC region. And post-merger, I went on to Gojek to lead the strategic finance function, where I was responsible for launching the new cities based out of Vietnam, Thailand, and Singapore. And lastly, to the current role that I'm at right now as the finance business partner for global product and tech. Let's move on to the next slide. So a little bit about what I do. There's three key pillars across the finance functions overall. So you have the budget and target setting pillar, you have financial control, and financial planning and analysis overall. So a little bit about each of these pillars. Budget and target setting essentially is there to allow you to understand how much capital you need to run your company, as well as understanding what performance targets are realistic to achieve on a year-on-year basis. The next step of it is on the financial control aspect of the business, where you focus on ensuring your business performance is on track with whatever budgets and targets that you set previously. And that then trickles down to the financial planning and analysis pillar, where you look to understand why variances arise, especially whether you overperform or underperform on targets. So that is essentially what I'd like to focus on a bit today, because it's clearly the most interesting part of any finance role, where you get to deep dive into the business and understand how the various levers you have to control a business move the performance on a daily, weekly, or even ad hoc basis. Let's move on to the next slide. Okay, so I'm going to walk everybody through a very common scenario of what it's like in my role. Like you get questions like this pretty often. But, for the sake of, I'm not allowed to disclose a lot of data, so I just created a mock case study for everybody here. So you are now tasked to use data analytics to understand the performance of a business that has three key products. You have product A, B, and C. C is a new launch. And across the three products, product A is the highest margin primarily because of the low cost of producing the product. Product B is a good balance of costs and sales price, therefore the margins on the medium tier. And product C is a new launch. You tend to launch with a promotional price and it tends to cost more, especially for the newer products. Therefore the margins are the lowest here. So you are now provided with historical sales volumes for 2020. And let's move on to the next slide. So this is something that you will be greeted with pretty often in my role and across various other roles regarding business analytics, which is raw data. This is definitely not presentation really. It's like a lot of numbers for you to digest and deal with. And it's just essentially a breakdown of monthly sales units across the three products that you have available today. Doesn't tell me much right now, but what happens when you pivot the table into a monthly view across 2020? Let's move on to the next slide. So this is something that you're going to be doing pretty often, especially if you interact with Excel a lot, which is this just pivoting data. So you can see you create the pivot table and then you just move rows and columns into the correct sections. In this case, months goes to columns and rows goes into product type. And you add the sum of sales units as the values. So let's just let it run through one more time, just for everybody to get a good sense of how pivoting works. And at the end result here, you're faced with like a total sales by month view. Let's go on to the next slide. Okay, so this is an improvement, but still not the best because you're looking at data on a monthly basis and you're looking at the comparative performance across the three products. So you now have a good understanding of the product C is a new launch. It launched sometime in June of 2020. And it gradually progressed from about 200 volumes monthly to 3,000 by the end of the year. Aside from understanding how product C launch and timing, you tend to also be able to tell that sales volumes have been rising on a monthly basis. This is easy enough for you to digest when you're looking at it and really thinking hard, but there are still way too many numbers on the screen for you to just give very straightforward insight for your audience. So what happens when you visualize this data? You move on to the next slide. Yeah, so you see with the visualization here, you're able to very clearly tell that, performance has been pretty great. Like you've gone from 3,000 units in Jan to about a 2.3x growth in monthly sales by December to about 7,000 units. This is a pretty positive picture if you're running this business overall. But what happens when you dive into another level of detail? What happens when you break this up into the individual product lines? Let's move on to the next slide. So you will see here that it's a very different story overall. First and foremost, product C has had very aggressive growth from June to December, and it's starting to eat into the volumes from the other product lines. What I mean by that is that if we look at product A, which is the blue line, it started the year in Jan 20 at 1,000 units sold monthly, and it closes the year in December 20 at 700 units monthly. So you can actually see that there's a pretty steep reduction in monthly sales volumes for product for product A, sorry. And then for product B, you can actually start seeing the gray line starting to stagnate after the launch of product C. So product B, given that it's a flagship, it starts to draw questions about whether we are prioritizing the right product lines when it comes to the launch of product C overall. I put up a summary, and this is just general best practice, which is to just place a very simple one-line summary at the top of your slide, which is saying that while monthly sales volumes continue to grow, product C is cannibalizing sales volumes from products A and B. We will need immediate action to address the change in product mix. So before we move on to the next slide, there's also some other aspects that you don't see visible on the slide itself. You have to take into consideration things like product margins, like I presented earlier. You will see that product A was the best margin product, but right now we are starting to suffer in terms of volumes. And product B in itself is a good balance, but once again, it's a further reduction in volumes. So this, when you couple it together with things like sales revenue and other data points with regards to customer satisfaction, will lead to a lot more details in terms of how you make a decision to either keep prices as is, or maybe you need to make a change in terms of the cost price as well. So in summary, let's move on to the next slide. So these are the key takeaways for everybody here. So first and foremost, in my line of work, you really need to have a point to your analysis. Like, everybody loves really nice looking graphics and really good looking tables. But if you don't articulate the main point of the work that you're doing, then it becomes very difficult to sort of sell the idea or sell the strategy that you're trying to put in place. The next steps, especially for the students here in particular, I highly recommend being well versed in a variety of tools and programming languages. From my personal experience, if you're looking at a starting point, Tableau, Power BI, and SQL is a really good starting point to be at, because it will allow you not only to visualize data, but to actually work with raw data that can be in the form of raw databases such as BigQuery or AWS. Lastly, for those of you who are on the search for your first job, I'd highly recommend taking the approach of showcasing your work, both in and out of a resume. This is mainly because if you highlight your achievements in the resume and I'm able to get visibility of it onto online repos like GitHub and Kaggle, it will really help in terms of making a hiring decision, because I will understand your level of capacity with regards to the tools, as well as your overall hunger and desire for the role. So that's the end of my presentation. Let's move on to Q&A.
All right. So thank you very much, Mr. Faisal. It is great to have you share with us, especially coming from a company which I believe a lot of our students are very familiar with. So right now we have about 5 minutes of question and answer before we go on to the next speaker. If it's the first time that you are using this format, all our attendees, if you have any questions, feel free to type it out inside the Q&A section, and perhaps we'll have time to take maybe 2 or 3 questions. And perhaps while waiting for our participants or our attendees to come up with the questions that they have, maybe a question for you, Mr. Faisal, would be, so you have been inside this or other roles that really depend on data for the past few years. How has data, and how has it shaped the world around us?
Yeah, I think that's a really good question. First and foremost, I can safely say that the velocity of data has evolved very rapidly. So a simple example I can give everybody here on the call is just when I first started out my job in P&G, a full year's worth of data was roughly about, say, 500 lines, full year's worth of transaction data. So when I joined Uber and Gojek, they were generating upwards of 5,000 to 7,000 lines a day per country, just based on order volume alone. So we are capturing a lot more data a lot quicker and with a lot more details, which allow you to make arguably better decisions because of the details that you have in place.
Great, thank you for sharing. Let me have a look at our Q&A if there are any questions. Okay, so it seems that we do not have any questions. Maybe another one for you. I know that, or perhaps data analytics was not a focus perhaps in the traditional education maybe 5-6 years ago, right? If someone is interested to pursue data analytics, to study data and to make sense out of it, what other options or what kind of habits would be good to inculcate?
So I think there's a lot of free resources available today. Like you can even look up YouTube tutorials on how to run specific analysis, but I'd honestly start with the basics, which is to do a lot of research behind what they call exploratory data analysis, because that allows you to, it's the first stage of the data science process, and it allows you to explain in full detail what you're trying to achieve and what kind of data you will require in order to achieve your objective overall. So another thing that I will also highly recommend is for everybody to brush up the business writing skills and communication skills, especially. While this may not necessarily be as technically demanding as, say, picking up SQL or picking up Python, I'd argue that this is equally important, because if you don't have the ability to communicate clearly and even write in a very concise fashion, then it becomes very difficult for people to see the work that you've done and for them to understand the takeaways that you're trying to explain to the audience.
Cool. Thank you, Mr. Faisal. We have one question from one of the attendees here. So the question is, I saw that you are using Excel to create pivot table. What do you think about the skill set of Excel? It wasn't mentioned in your suggested tools. So perhaps in this instance is whether is Excel still something that is relevant, or what are your views on some of the more specialized tools?
Yeah, I honestly say that Excel and general spreadsheet tools, as time progresses, it seems to be a more finance-centric tool. I think what Excel does better than the other available tools today is things like financial modeling. But as a whole, I'd also recommend that if you are wanting to focus your career in the direction of finance, then Excel is pretty much non-negotiable at this point, because it's kind of like a core tool that people use on a day-to-day basis. I excluded it from my required tools for data analytics mainly because it's not really required for somebody to be very well versed with spreadsheet tech, and Excel tends to be owned by finance professionals overall. I hope that answered the question.
Okay, thank you. Perhaps we have time for one last question, which I think is pretty interesting. The question here is, how does one balance between using data for analytics and protecting the privacy of sensitive information that was gathered?
This is a great question. I think first and foremost, the best organizations from my experience have essentially been able to anonymize data and minimize access to said personal data. So by right, there should be a very small team that has access to that data. And in this space, we call it PII data, personally identifiable information. It is most ideal that information is anonymized. Like in terms of analytics, there's no reason for you to need to know somebody's name, somebody's address, for example, because you can do a lot of that via data modeling. So with regards to that, I honestly say that we should stick to the approach where we err towards personal privacy versus focusing on delivering extremely detailed analytics, mainly because that is the stand that most companies take today.
Perfect. Sounds good, Mr. Faisal. So for all our attendees here, I understand that you may have a lot of very interesting questions. So what we will do is I will take note of some of these questions, and perhaps we can follow up with an email to help you to understand or to sort of answer your questions. Right now, I would like to be able to introduce you to our next speaker. Okay, so our next speaker is Mr. Idali Ali. Okay, he's from MasterCard Data and Services, and he's here to share with you a bit more about what he does at his workplace, what does it mean to be a data scientist, and how data analytics has been used in his workplace. So, Mr. Idali, feel free to unmute your mic and share your screen.
Hi everyone, how's it going? Right, so I'm gonna share my screen. Right, so I'm Idali. I'm a data scientist and also a data science manager here at Mastercard. Specifically, I lead the data engineering and analytics work in the new product development division in Mastercard's data and services. So my presentation for today would be on building data science solutions at scale, which is something that I do every day at work. So give me a second, my slides are not working. All right, so the question is, what is scalability and why it's so important for big data projects? So traditionally, retailers have been using data analytics to improve logistics, pricing, assortment, promotion, and marketing efforts, right? But the deluge of big data with e-commerce and the availability of open source machine learning tools, they create both opportunities and challenges for scalability to retailers. So doing data science at scale now involves a radically different approach towards picking the right processes and tools in data preparation and data management, and also involves a lot of analysis, visualization, automation, and execution of models. There are many problems where when you add more data and additional of large data sets to model training leads in impressive results and better models. But sometimes the question is whether the models that you build is slightly too complex for implementation or deployment, or whether that 2% improvement in that model really helps with delivering values to your end users. In this case, it's the merchants, cardholders, or also other entities. So let's talk about scaling AI solutions for production. So we know that the scale of data and operations has grown exponentially over the last few years. So for example, here at Mastercard, we have about 249 million cardholders in the United States, and about 725 million cardholders in the rest of the world. So imagine if you have to build a prediction model, right? So something that we do all the time, let's say an attrition model that would predict the probability of a cardholder like you and I, right? Given 12 months of data. And you'll need to get new predictions every hour. Can you imagine the complexity of this project and how much work it needs to that will require just to deploy this model out? So to build data science projects or tools at this scale usually requires requires the data science strategy to put scale at a foundational level. So whenever you have discussions about scale, it must be done very early in the design process, right? And this will determine the choice of things like the data storage platform, the analysis platforms, and also the tools that you want to use to visualize your work. So it would be really naive, right? And it was a lost opportunity if you were to proceed with solving a data science problem without thinking about scalability. So for example, there's this very cute that slide that I have, right? It tells you it illustrates how different it is visualizing, or I would say building a product from your local machine as opposed to, say, getting it deployed into production. So let's say you sign up for a Coursera course and you just learn how to write a simple program, hello world, Python. So that would take maybe one line of code, but it doesn't really do anything. So in my position as a data scientist, as an individual contributor as well, I do a lot of I build a lot of models based on some very complex architectures. So for example, this code that I've written is a TensorFlow variational autoencoder that we use for attrition modeling, and it's just 10 lines of code from my end. But if you want to scale it up and put it into production, this would change to like 267 lines on Scala written by a data engineer. So you can see, how a very simple code becomes really complex when you want to scale up. And the understanding that things get really complex as you scale up your operation has to be at the foundational level when it comes to discussing the scalability or scalability strategy. So let's talk about the dilemma of scaling. So many times, organization starts with the system on hand, such as open source languages like R and Python, and without having scalability in mind, you start creating prototypes on your notebook, right, on your local machine, where data is kept on your hard disk drive rather than on cloud. So what happens is that as you scale up, and if you want to say, like, let's say you create an awesome model that can predict whether you're gonna earn $1 million in 2 days, right? And it's 99% accurate, right? And you want to sell this to people. And let's say you have like 200 people, or say 1 million people that sign up for your app that you created, right? And to get more data coming in, then you know that the platform that you created obviously cannot withstand that much data coming in. So that's when you know that, hey, I didn't think about scalability when I implement my model. And then you would think about then investing a lot of money on big data tools just to scale up your operations. But this will probably be too late. So what we want is that every idea that you have or every solution that you devise, it should have like scalability at heart. Over at Mastercard, what we define AI is not just creating models, but also models that can both give you a very good performance and also be able to automate. And that automation is totally dependent on how scalable your decision or how scalable your decision systems are. Usually, I usually tell the stakeholders that if you think that the data is too big to fit on your computer for analysis, then it is a big data problem, and then it requires a skilled solution. So if contrary to like what Faisal mentioned earlier, we don't really use a lot of Excel in my workplace because we have like petabytes of data. So it's a different approach for different requirements, and this is again, when we devise solutions, we have to think about scalability. So when that happens, as in over here at Mastercard, where I deal a lot of like trying to come up with strategies for scaling, there are some very high-level things that we need to know. So always make the decision early. Again, when you think about any idea, any simple model that you think that you want to have, that you think you want to sell it to people, you think about the crowd, you think about the market, you think about how you're going to deploy it, and then you can make the decision early. Like whether you will require large computational resources, or whether you would want to use like cloud computing, or keep your data in a distributed resource. And you also want to look at the tools that are available for scalable data science. So over the tech stack here at Singapore, over at Mastercard, we have 3 of them. So the first one is the databases and distributed computing, which is generally done by data engineers. So what they look at is to optimize the how data is kept, right, and queried, so that they can be delivered at the shortest time possible. We have the data scientists. So these are folks that come up with algorithms, and we try to look at different architectures, and then we try to figure out which one gives you the best bang for buck. And then you have the systems programming. So these are the machine learning engineers. Usually, what happens is that they get the models from the data scientists. They report it into a system, right, that is compatible with the infrastructure of your enterprise systems. So again, when you think about high-level deployment of your solutions, always have strategic scaling when it comes to mine. So now we look at different ways to tackle big data problems. Question is, do we really need 1 terabyte of data when we train our models? Do we really need to sample our data sets? Do we really need to train your data set on like 90% of your data that are available? The question is, well, it depends. So let's say you have a problem, right? Let's say you have, this is a problem this is like the simplest model we have here at Mastercard. So let's say you have a cardholder, you want to build a churn model that predicts whether someone would stop using a card entirely. So this would take about, cardholder level of transactions for about 24 months, and you have a gazillion of rows, right? Probably going to take about petabytes worth of data. You also have information on merchants, you have holiday data, and you have also alternative data like weather and geographical information. Now the question is, how do you merge all this data together and how do you pipeline them together? And these are all questions that needs to be answered before coming up with solutions. How each data from different sources are pipelined, and this will help you come up with a better solution. So at the machine learning process pipeline over here at MasterCard, we have 4 key stages, of which the first 3 are usually led by the data science folks. We have the feature engineering and data transformation folks, where we do a lot of like sampling, joining of tables, dimensionality reduction. And then we do a lot of training of machine learning models that are built on top of big data tools. And then we run the evaluation program. And lastly, which is the most difficult part, is trying to apply the model to all cardholders and also monitor the performance. By definition of performance, we look at 2 things. First, we look at the ability of the model to predict really well. And the second one is probably to look at how it is resilient to the impact of having lots of data coming in. And also its resilience when it comes to if, let's say, one system is down, whether it would still run, right? So you can see it's the process is very it's a bit different than most data science projects because again scalability is at the heart of it. When it comes to creating a machine learning pipeline for supervised learning, also we look at things like partitioning customers evenly, right? And also doing a lot of dimensionality reduction so that our features are less than about 100, right? So the numbers are just arbitrary, but from experience, features that are less than 100 gives you the optimum performance for the minimal computation. So for machine learning pipeline, scaling in terms of transforming your data into the right shape and pattern would be really important. So the next question we have is usually about what models to use. Of course, if you're in academia, then the emphasis is more on coming up with the best model possible. But as you can see over here, sometimes the simpler models give you a better value to the end users. So the model on the left is a very simple logistic regression that runs on 0.01 microseconds and gives you a pretty good accuracy, but it doesn't really require a lot of computational resources. The second model using a transformers, it's the prediction time is really high, right? Reads are really long at 1 microsecond. It's about 100 times slower than logistic regression. True enough, it's a better predictor of some conditions, but it requires a lot of things like you have to run it on a third-party resource and you have to vectorize the data. So the question again is which one fits your requirements. Over here at MasterCard, obviously we don't use logistic regression, but we probably use models that are I would say pragmatic, right? The one that gives you a good prediction for the minimal amount of computation. So what comes after model building? Again, when you build a model, you want to look at, say, whether you're using too much data, right? Or whether you are using way too much computational power to generate the same, accuracy. And these are questions that always have to be answered whenever scalability comes to mind. All right, some best practices for scaling, right? And these are a bit different than, again, the toy projects that most folks are very familiar with. So we look at things like, we should stop prototyping on local machines, right? What we want to do is to use data science platforms on the get-go. Things like, if you're on an AWS or GCP systems, then you want to create prototypes based on that system alone rather than running it on your local machine. When you want to save your work, right, use version control system, right? It helps you monitor your progress and also figure out, if there are any changes into your work that could affect the deployment of your model. If there's a need to roll back your models because of some reasons, then you have a clear documentation for you to revert back to the previous version. You will also want to use virtual environments or containers instead of installing your packages on your local machine. This helps your work to be more fluid when it moves from one system to another. And we also talk about benchmarking. So when you talk about models, how good they are, we should always talk about previous models and how it performs better again in terms of the ability to give really good predictions and the speed of inference. And last one in terms of tech would be deployment. Right? Again, always have more than one versions in case the other versions don't work. And lastly, I feel like the most important one would be sharing, be open and be transparent about failures, right? We should always be open about, what went wrong, right? So that, going forward in the future, you wouldn't make the same mistakes again. Lastly, MasterCard, we've been scaling up data analytics for, 20, 30 years now. So we are here even before, the big banks were around. We can process 500 transactions per second, right? In comparison, Bitcoins, you process it at 4.6 transactions per second. So we have that experience. We've done it before. We know what's right and what's wrong. And the question is, whether you think about when it comes to scalability, you think about time, right? And there are some things that money can buy, like time, right? But for other things, there's always MasterCard. Right, thank you so much. That's the end of my presentation. I'm ready for the Q&A.
Thank you so much, Mr. Idali. That was really enlightening, especially coming from a company that is something which everyone is fairly familiar with, right? We transact using MasterCard services almost on a daily basis, and it's good to be able to have some insights as to how how each of these things play with one another, as well as how they are able to affect the world around us. So, as per usual, as what we had earlier on, please feel free to type out any questions that you may have for Mr. Idali. We'll pick a few questions and then we'll move on to the next agenda.
I see some questions on the screen. Are these questions that I should answer?
Yeah, you can answer some of those questions if you want.
Right. Right. I have Kenneth Liang. Right, good question. How do you see a role in data analytics evolve in the next few years? So that's a great question. I would say in the next few years, what's going to happen is that everybody's going to be very familiar with data analytics to a point where there isn't a need for you to have a data scientist at the end of the pipeline to come up with models. Things are moving really fast, and you have things like AutoML that doesn't really require human at the end of the modeling pipeline. So I would say in the future, what's going to happen is that data analytics is going to be democratized, meaning to say everyone could have a chance to come up with models, trying to come up with interesting solutions based on the data that we have. The limitations would be the access to data. So that's a tricky one. But otherwise, I see in the future, data analytics would be some sort like, math for everyone. It's a useful tool for you to solve most of the problems that you face, regardless of the industry that you're in. And similarly, I feel that it's not, unlike what it is right now, where data science is, it's kind of siloed, where you have to have a certain skill set to work on it. I see data science or analytics in the next 5 years to be something that is, anyone could just pick it up. Obviously, right now at this stage, I don't think it's kind of difficult. The learning curve is pretty steep, but in the next 5 to 10 years, I feel that it's going to be an easy, anyone could just pick it up, right? Anyone could just pick up data science, right? And then, or data analytics, to be specific, and to use them to build really cool products in the future. Right, so the next question would be, recently, Lin and Fu, Visa is imposing a surcharge for their service. Will MasterCard do the same since Visa has a bigger membership strategy? Right, so yeah, this is a question probably not for me to answer because I'm working in new product development. But I would say MasterCard has a different strategy to Visa. So MasterCard's emphasis, if I'm not wrong, and don't mind my words on this, but our emphasis is that the merchant should bear the cost of the surcharge, not the customers, you and I. Again, every company has their own strategy, but we feel that we have a different approach where we keep customers like you and I, cardholders, at the core of our service. So right now I think we feel that the cost of that surcharge should be on the merchant because they're using the service. Visa has a bigger market share. What's your strategy to maintain that market share? The market share thing, it's an interesting question. So the question is, I would say analogy would be Apple and Windows. So Apple has a smaller market share than Windows. So Microsoft. So obviously the strategy would be different. For MasterCard, what we focus more on is innovation. So there are a lot of things that you don't know, which is within. There are a lot of infrastructure that we're using every day. Things like Pay Now, right, which is a VocaLink system. VocaLink is a company that MasterCard has invested or in fact purchased. So MasterCard as a company, we think a lot more in terms of, we do a lot of innovation because we have a smaller market share. But having a smaller market share doesn't mean anything. It means that we have to innovate. And I feel that that's where MasterCard is, it's at the forefront when it comes to payments because we're good at innovating. We're good at spotting trends earlier, right? So I would say the market share thing, it's better if you have a bigger market share, obviously. But our focus is more on innovation and some of the stuff again that you've been using are all MasterCard was from MasterCard. Pay Now, right? Simply Go, those are all MasterCard systems, or they were from MasterCard's subsidiaries. All right, so next question by Eric Pang. I saw AI used for card chain prediction. Can share how AI is used for fraud detection? Yes and no. So yes, I can tell you how it works. No, I can tell you how it works. So how it works is it takes in your historical card transactions data, right? And then what happens is that it weighs, it puts some weightage into some categorical and transactional features on your data. Right, and based on that, it tries to predict whether a certain transaction is a fraud or not, right? So it's a difficult task because the question is, sometimes you get false positives and sometimes you get false negatives. So the question is, would you want a better false positive and false negative? But the heart of it is that the models that we use for fraud analytics, and in fact for most of our models, have to be interpretable. The models that we create, right, are not we don't really use, we use a lot of deep learning models, but we find that a lot of really complex models that gives you a very good score is not interpretable. Meaning to say, if as an end user, let's say I get one of my cards flagged as fraud, right? And because of that, something happened and I lost $20 million, right? I want to know why my transaction was flagged as fraud. Now over here at MasterCard, what we can do is we can tell you why your fraud, your transaction is flagged as fraud, right? Because our models are all interpretable and they are all easy to understand, right? So that's how we build a model. How it works on the back end, it's a proprietary information. I'm so sorry, I can tell you that. Do we have time for more questions, Hafiz?
Yeah, I think we have time for one last question.
All right. So how often do you build your own model and architecture, and how do you verify its efficacy? That's a terrific question and something that we do every day again. So, okay, the question is gone now. Did someone delete it? All right, sorry, I need to scroll up.
Sorry, the question is in the published.
Right, okay.
You can click on that and see.
Sorry,
no worries.
I work in tech, but I'm quite a tech dinosaur, right? Okay, so how often do you build your model? So how often do you build your own model architecture? Yes, that's another good question. So how often depends on a couple of cases. Now, data science isn't just about, again, creating the best models that you can find, right? That is in the realm of academia. What we're looking for here at MasterCard is models that can deliver value to your end users, right? So we will want to build models that can value add to the services that we offer to our end users. So how often we build our own model is dependent on whether there's a newer model architecture that could bring about the additional value. Right now, I'm involved in a project where we are doing a wholesale change the way we model, the way we deliver our pipeline from the warehouse to your analytics box to the delivery to the cardholders, right? And we want to go faster, right? We want to go faster. We want to get the models out. We want to have, like, instead of PDFs, we want to have like a fancy front end, and we find that that can offer a better value. So again, how often you build your own model depends on whether there's a business case for it, and whether that business case warrants a new model. Usually, I would say we do a lot of this all the time, and in new product development, where I lead a team, this is exactly our task. Our task is to think about new solutions to new problems, and also think about new solutions for existing problems, and how they can change things, and how they could bring more revenue to the company. And the last question would be, how do you verify its efficacy? Yeah, so to verify its efficacy, it's kind of simple. So again, the efficacy, by definition, we have two of them. One is the ability of the models to predict, right? So that is done, with a couple of things. So the usual metrics that some of you are familiar with: MFC, MAFC, or MSC. We also look at efficacy in terms of its ability to come up with a prediction without ingesting too much personal data. And lastly, we look at the efficacy in terms of, again, the value that it's going to drive. If our model is good, 90%, like let's say right now it's at 89%, and we can come up with a model that has a 94% accuracy, but the value that it brings to the end users is only like $2, right? So then would your model be, are you building a very good model or not? So to round off everything, I would say the big difference between what you have at MasterCard and the projects that you build on your local machine is that, again, two things. One, we are focused more on scalability, how well you can scale up your model so that you can spread the good stuff to all our cardholders, the 700 million of them. And secondly, the value that you bring to these folks, right? Whether the models that you build, right, whether it adds another dimension to whatever that the end users are using, whether it's a better fraud detection system, whether it's the way we offer, and we do this all the time, the way we offer promotions to customers who are in the loyalty program, and also things like providing really good insights for governments to analyze their economic situation in their own countries. For example, we do a lot of like COVID analysis pre and post pandemic as well. So yeah, our efficacy goes beyond how well the model performs. But then again, to summarize everything I've said, the main point of doing this is so that our customers, our cardholders, and all stakeholders, they get the best services that they can possibly get through our range of products that we offer.
Great, thank you so much, Mr. Idali. I think my key takeaway for your presentation is that what we are doing may just be the surface of what data analytics can do, right? And there is so much more ahead that you can do, so much deeper that you can go. And this is where it starts to affect the people around you, and it really helps to give you a better understanding as to how the world has evolved, how it has changed, and how it has been impacted by the data that we all produce on a daily basis.
That's right. And it's a pleasure to be in this call. Great to know all of you are interested in data analytics. We've just started, right? It's a journey. We're not even like halfway there. In the future, we're gonna have like all cool products coming in, new ideas, new implementation of new tools, right? I believe in democratizing data analytics to everyone. And the first phase of doing that is to share what we do here at MasterCard. And hopefully everybody gets a good takeaway to my otherwise pretty dry presentation. Thank you.
Thank you, Mr. Idali. I really appreciate your time. So I know that there are some other questions that you guys may have, but we do have a shortage of time. However, one of our earlier speakers, Mr. Faisal, actually saw some of your questions and he thought they were pretty interesting. So he has actually come back into the call. and he's going to take a couple more questions perhaps. So for the benefit of those that asked, he has taken the time to answer them. So Mr. Faisal, please. Perhaps we can start with one of the questions, which was, what sparked your interest in this whole, data analytics or, in this area, in this field of study?
So I think the main thing that really got me interested in this scope of data analytics, even though like it's not necessarily a discipline that crosses over well in finance, is mainly the fact that we'll be using pretty traditional tools. We were still using the standard Excel financial model, and a lot of the models were based on averages and run rates, because that's like a really convenient way to model a business. I got that exposure towards more advanced analytics methods when I was in Uber. Uber, my role in finance there, like it wasn't so much about building models. It was actually more about looking at the models that data scientists had built and then determining the efficacy, like how reliable this model is against the actuals. And whenever there were huge variances between the predicted result and the actual result, like we deep dive and we do a variance analysis to it. So that's what really got me into this whole data analytics space, and that's really kind of where I started building some of the skills. And of course, like I'm nowhere near as skilled as Mr. Idali on the call, of course, but it's more of like deepening the knowledge and understanding that there are a wide variety of tools you can use to predict your business.
Cool. Thank you so much. I think that is something which a lot of the participants, especially our students, who may have had a taste of what data analytics is like, and perhaps they are asking to see if it's similar to your experience. Maybe we'll do one more. I think this is something related to one of the advice that you had, which was what are the example of a portfolio? How can you build one?
Yeah, so I've noticed like this primarily because I've been hiring out roles on my team, and I tend to look for people who have been able to showcase previous work and previous achievements. Actually, this data analytics challenge that you all are working on is a great example of how you can build a portfolio. This is of course subject to the rules and regulations of the contest, but as long as you're allowed to publish your analysis and publish your results on something like GitHub, then that makes it a lot easier for somebody like me to read through your resume and actually see like what the project was about. So I'm not necessarily advocating that you come to every interview with a data presentation. I'm more advocating that you make it available should the hiring manager be interested in finding out more about your projects.
Cool. Thank you so much, Mr. Faisal. I think it's really great that you are able to help answer some of the curious minds that we have online right now. And we really want to thank you, both you and Mr. Idali, to spend some time on a Friday afternoon. I know you guys have a very hectic work schedule, and we really appreciate the time that you guys have taken to provide additional insights to a lot of our students and our future data scientists and data analysts perhaps in the future. So with that, I'm going to bring us to the final portion of today's agenda. And this is where I will be speaking, right? So my name is Mr. Hafiz. I'm currently teaching under the electrical engineering, under School of Engineering at College East. And I wanted to bring forth, a different perspective. So earlier on, you had looked at some of the areas in terms of finance, in terms of, in the fintech industry. I wanted to be able to give some additional insights to all our attendees here on how data analytics has been very useful in terms of the engineering side as well. So early on, I saw there was one question, right? And this is, I believe, a question which a lot of our students may have, which is, if I'm not good at math, can I still do data analytics? And in my presentation, I hope that I'm able to help you understand that it's good to have, but with all the tools that we have very strong computers, we have a lot of very powerful devices that can help us to compute all of this. Perhaps Okay, even if you do not have a very strong background in mathematics, you'll still be able to make sense of data. So tune in. Okay, I'm gonna share with you a little bit more. Now, before I begin, I'm going to play a short sample, a soundbite. Okay, and I want you guys to listen closely and tell me if this is something that is familiar to you. Okay, so I know that's a little bit of an older song, okay, a bit of an okay boomer moment there, but I hope that, okay, this is something which some of you are able to understand, able to hear, process the information, and something that would perhaps spark, okay, some form of recognition, something that you've heard of before, and perhaps you even know what notes are supposed to be played after that. So if you're able to do that, if you understand the process that your brain has gone through from listening to processing and figuring out what song is that, I can tell you that the rest of this presentation will be very, very easy for you. Okay, otherwise, okay, I'm going to give you some brief information as to what we're actually doing and why we need to understand this. Now, the main topic or the main area that I'm going to be covering is on vibration. Okay, and we are going to see how we can use vibration to do some predictive analysis on machinery that is powering a lot of devices around you. Okay, from the pumps that power or that provide water to your taps every day, to the fans that make sure that devices run cool, and so on and so forth. So when we talk about vibration, this is a mechanical phenomenon where oscillations occur about an equilibrium point. Okay, I know there's a lot of musicians out there, right? So this is something which I hope you guys are able to relate to. So when you have a person who is plucking a string on the guitar, you can clearly see that it is vibrating. And this vibration is the phenomenon itself where it moves about an equilibrium point. Of course, moving your fingers around the fretboard will produce different sounds. This is the same as the speakers that you may have that produces the sound of a recording or playing a song and so on and so forth. So typically a speaker will have a diaphragm. At the back there is a magnet that moves back and forth, and it is this movement of back and forth of the air molecules that produces the sound, produces the different notes, the exact same item, the exact same phenomenon that you are able to hear my voice at this very moment. Why do we look at vibrations? This is because there are some oscillations that are desirable. There are some which are unfortunately not. Okay, here's an example. Okay, this is a bridge that was built. Okay, it's called the Tacoma Bridge. And you can clearly see that, okay, this is something that is straight out of a movie, right? It's vibrating uncontrollably, eventually causing it to collapse. Okay, this is where vibration is undesirable and something that we want to avoid. Okay, something that we do not want to happen because it can affect lives. Okay, it can affect a lot of property, a lot of cost is involved, something that needs to be avoided where possible. So now the question is, how can vibrations be measured? Okay, earlier on we talked about, or rather we heard the presentations from Mr. Faisal and Mr. Idali. Okay, they have the luxury of having these online transactions to help you understand. Okay, how many people are in a certain area buying McDonald's on this day, for example. Okay, however, when we come to engineering, a lot of the data that we require, you need to be able to find a way to capture that information. So in this instance, okay, to be able to measure vibration, we are using a sensor that is called an accelerometer. This is a sensor that measures a change in velocity on an axis. Basically, as the accelerometer moves up and down, it produces sensor data that reflect that. So if I were to move my accelerometer up and down, you should be able to see the corresponding information being produced as data. This is how a real vibration data is being collected. Okay, over on your right, you can see this is what we call an AC induction motor, and this is being used to pump chill water. So the air conditioner that you're enjoying right now, okay, and the air conditioner that you feel or not feel, okay, when you're in classes, it is all being powered by machines that look like this. And if you imagine any of these machines were to be offline or if they needed to be maintained, okay, then okay, you may not enjoy the luxury of having cool air during your wonderful lessons, right? So what we do is we have all these accelerometers that are mounted on the rotating machinery to help us capture the data. So as the machinery vibrates, as it moves in different directions, we can capture this information and see the data to tell us a little bit more about how the machine health, how is it doing. So this is how it may look like. Okay, when you put these accelerometers on those machines, you go and turn on the machinery, it starts to vibrate. This is what you look like. Okay, and this is a good representation on what we call raw data. So raw data from machinery is not very useful for humans. If you ask me, this doesn't really tell me much, right? However, we can perform some mathematical functions to help us analyze the data into something that is a lot more useful. Okay, so the person who asked the question whether you need maths or not, okay, this is where you will find your answer. Okay, Fourier transform. Okay, this is a tool that allows us to view time domain data into frequency domain data. Okay, this is how it looks like in all its glory. Okay, I know for a fact, okay, the moment we see mathematics and we see more Greek than actual numbers, it can get a little bit scary, right? However, the good thing about data analytics and the movement towards digitalization, people are able to program, to inculcate all of these formulas into bite-sized pieces that we can just reuse. Okay, so in short, you do not need to know exactly how it works. What's more important is you just need to understand how it works. Okay, and later on we will see why it works. So there are computers and a lot of machinery that is readily available, that is open source, being maintained by a lot of very, very smart people, and we can just make use of these tools to help us to do the computation. Okay? Now, earlier on we talked about Fourier transform and what it produces, but before we go into how we can use it, it's important that we understand this term called a frequency domain. Now, I want you to look at what's on screen. You have a guitar. Okay, I know some of you may be familiar with what is the guitar. Okay, others may not. But a guitar typically has 6 strings. Each of these strings will produce a different note. If you go from the left to right, if you look at the picture, you will find that the note being produced will change from a lower note. So your bass notes will appear on the left. As you gradually move from string to string, the further to the right you move, the higher pitch it will produce. So this is how a guitar works essentially, and that is all that you need to know to understand this portion of the presentation. Now, if you look over on the bottom left, you will see that there's a graph. Okay, there's nothing on the graph yet, but I want you to look at the axis. You have amplitude and you have frequency. How is this useful? When we look at the frequency domain graph, and if I were to pluck a guitar string, for example, this string in the middle here. Okay, those of you who have studied music, you would know that that is the A string producing a very specific sound, vibrating the string at a very specific rate to produce the sound, okay, called the A note. So how does this appear inside our frequency domain graph? It appears as a peak, okay, at 110 Hertz. This corresponds to the musical note that is being played. Okay, we call that the frequency. And we also look at how loud that particular signal is. We call that the amplitude. So if you look on the x-axis, you can see the frequency. As it changes, it will appear differently, okay, on the x-axis. And depending on how loud it is, the peak will become higher or taller or shorter if it's soft. So essentially, this is how your frequency domain graph works. Let's take it a step further. I'm going to pluck the same string, but I'm going to pluck it harder. Okay, meaning I'm going to play the note with much greater force. So same string, same note, but the moment you pluck it harder, okay, earlier on we talked about amplitude or how loud it is, you will find that the amplitude will increase because it's much louder now. You will find that the peak would have increased. So it is still playing the same note. It is still playing the exact same frequency, just that it is louder. So that's why you can see the amplitude increase. Next, what do you think will happen if we pluck a different string? Okay, as what we have talked about earlier on. Okay, we pluck a different string, a different note will be played. the rightmost notes, rightmost strings will play a much higher frequency noise. Okay, so you would expect to see a frequency or a peak at a different part on the x-axis. I'm going to play that again. I want you to look on the x-axis. Play the string, it's a different string. It's a higher frequency, therefore it appears on the right-hand side. Okay, in this instance, this is the B note, I believe. Okay. Now, the question is, okay, I want you to look at the frequency domain graph. You see that there are two peaks. One is blue, the other one is green. I can tell you that the blue one corresponds to the blue string that is being played. Now, the fact that you can see two peaks inside your frequency domain graph tells you that there are probably more than one string being played. Now, if you're able to determine, okay, that this is a higher frequency, meaning that it is producing a higher pitched sound, this can only mean that the string on the right of the blue one is the one that is producing this particular note. Okay, so this is a form of deduction. Okay, looking at the data that you have here, you're able to deduce, okay, based on what I see, I know two strings are played. The second note is a much higher pitch. Therefore, it must be a higher pitch string, which is the one on the right. Now, what if a chord is being played? Okay, so for those of you who are not familiar with what is a chord is basically when more than one note is being played at the same time. So in this instance, I have three strings that are being played together. Since there are three strings producing three different notes, you can expect three different peaks on your frequency domain graph. Depending on how loud they are or how hard they are plucked, they will have different amplitudes, okay, different heights. So in this instance, okay, you are able to clearly see, okay, or you're able to clearly determine which notes are being played just by looking at the graph. And what is the sound being played other than just vibrations or oscillations of the guitar strings. So coming back to our rotating machinery, okay, our rotating machinery, they follow the same principle. There are different parts of the machinery and they will vibrate at different frequencies, meaning they will play different notes. They are playing their own song. Okay, to give it an analogy. For example, the shaft may produce a note that looks like that. The coils, okay, may produce a note that looks like that. Okay, the blades may produce a different note or a different frequency, different sound, if you want to call it that. So, once you have all of these three things coming together with you, what you will find is that as a result, when all of these different noise, these different vibrations, when they interact with one another, it produces a resultant waveform that is very, very difficult to understand what's happening. Okay, if you see this waveform, the white color waveform on the right, this is exactly what we have seen earlier on. Okay, it looks like a bunch of garbage data. How can you make sense out of this? This is where you use your computers, okay, all of these tools that you have available for you. You just have to use the right one, understand what it produces. So in this instance, we are going to apply it to our machine vibration. So this is our original data. A lot of information. We're going to use our machinery to help us to do the computation. Eventually, this is what we will see. So very clearly, you can see that there are some areas which are not like the other. There are some peaks that you can see, and this corresponds exactly to each of the parts that are rotating earlier on. So when we look at frequency domain, when we do, or rather when we collect this data from our machinery, by using data analytics, we are able to transform the data into something that's a lot more useful. In this instance, we're able to separate out each of the different frequencies that each of the rotating machinery, the different parts are producing. And if you are able to know which parts are producing the which notes or which frequencies, we are able to determine whether are they healthy or are they not. You can imagine that if the shaft is imbalanced or if the weight is not equally distributed, you would expect to see a higher vibration in that area. Similarly, if, for example, one of the fan blades has more dust, or if it's broken, or something has happened to it, you can expect that particular frequency to change, a change in amplitude, a change in frequency. This can tell us a lot more about the health of our machinery. So when we look at all of this information, you can use all this data to do a lot more, and that is the study of online condition monitoring, and to use that to do predictive maintenance, which is to say, I can say, okay, there is something wrong in the coil, and this has a lifespan of about maybe 2 more months. We better do something about it before it catastrophically fails. Okay, and this is how it looks like in the industry. Okay, so looking at this information, I can look at live data from my machinery. For example, okay, you look on the bottom left, a lot of garbled data, but on the right, you can clearly see the peaks, and each of these peaks would represent or would be able to tell you how each of the different parts in the machinery is functioning, whether are they healthy or whether they are not healthy. Okay, so I'll give you one last look. Okay, and if you're interested to find out more, feel free to reach out to me. I'll be happy to go through some additional materials with you. With that, that is a brief introduction as to how data analytics is used in the engineering field to do predictive maintenance. If you have any questions, anything that you want to ask me, feel free to type it in the Q&A. We'll spend about maybe a few minutes to go through some of these materials. So just checking with everyone here whether you have any questions on your end. Please feel free to let me know. Okay, so if there are no questions, I understand that I'm the only one stopping you between the weekend ahead. So what we will do is, if you have any questions, anything you want to know more about, feel free to reach out to me. I understand that there are some questions that are still available that hasn't been answered yet. We'll have a look at that, and perhaps we can answer them on a different time. Nevertheless, that is the end of the sharing session today. I thank you for your time and for your attention for the past couple of minutes or few hours. And with that, this is the end of the sharing session for data analytics. Thank you, everyone. Have a wonderful weekend ahead. That is all. Thank you.
Thank you.